This section is about using your calculator, so please make sure you have your calculator. And we are going to use right triangle ratios to find we're going to use the calculator to find all 6 of the ratios, and we're also going to solve a right triangle. It's important that you know how to change the mode of your calculator because you are going to be inputting an angle, and your calculator doesn't know what type of measurement you're using for that angle. So on the Inspire, the way you change your mode is with the mode button, and you want to make sure that you're set to the proper mode, either radians or degrees, depending on how you are. Also, you can always get out of this mode button on the Inspire by hitting second quit. If you have a different type of calculator, I called it Inspire, the 84. If you have a different type of calculator, please speak to me and I will help you get your mode set. On the 84, you can also see the mode up at the top. It shows you what you're in, so that's helpful. If you're ever wondering, you can always do the trick of doing tangent of 45. If you are in radians, the answer will be 1.6 something. If you are in degrees, the answer will be 1. So that's kind of a trick, just to, what am I in? And then you can check that way. So some examples are tangent of 23 degrees, 42 minutes. Before my calculator understands that angle, I have to do the conversion to change minutes to degrees. So I have to say, well, 42 minutes, if I want to change minutes to degrees, I know that there are 60 minutes in 1 degree, so I'm going to try to get the minutes to be eliminated. So I'm going to put 60 minutes on the in the denominator, and I'm going to put 1 degree on the top. This will cancel my minutes, and then I'll have an answer that's in degrees. So I'm going to do 42 divided by 60. And that's 0.7. And so I'm trying to do tangent of, well, I already have 23 degrees, so 23.7 degrees. My calculator has to be in degrees, so I'm going to change my mode, degrees, hit enter, and then I'm going to quit out of there. I'll do tangent of 45, wait, not 45, what was I doing? 23.7. And that gives me the tangent ratio that my calculator can calculate for me. So we're going to get used to rounding to 3 places to the right of the decimal, so 0.439. On the 84, we don't have a separate button for cosecant, cotangent, or secant, but we can always do 1 divided by sine. And so we can do 1 over sine of 19 degrees. This one is in degrees, so we can just go ahead and do that. 1 divided by sine of 19 degrees. And 3.072 is the ratio for that one. If I don't see any marker on my angle measurement, that means that it's in radians. So for these last 2, we're going to be in radians. I'm going to change my mode. If I want to do cotangent, I'm going to do 1 over tangent of pi over 8. You should be able to get comfortable with changing your mode. It will happen a lot. And the pi button is right here. 2.414. And then even though this one doesn't have a pi on it, I know it's radians because there's no notation on it, so that means radians. So I'm just going to do 1 over cosine of 1.24 to get the secant of 1.24. .079. And that's how we use our calculator. Please make sure you're comfortable with changing your mode. Please pay attention to what your mode is. Just a notation thing, I want you to be aware that we use Greek letters like theta when we're talking about angles, and usually we use like a lowercase letter if we're talking about side lengths. The soh-cah-toa that you learned in Algebra 2 is going to be a useful way to remember that sine, if I want to find the sine of this angle, I'm going to go to the opposite side over the hypotenuse. That's the soh part. If I'm using this angle over here, I would be using the adjacent, the one that's labeled as adjacent, as the opposite side. So it matters where our angle is, so we have to pay attention to that. And we just have to remember, soh-cah-toa is how we remember those ratios from Algebra 2. Some other tools in your toolbox as you're trying to solve a triangle should be the Pythagorean theorem and the sum of the interior angles of a triangle. So just be careful that you're grabbing the right tool. The Pythagorean theorem is going to help you if you know two sides already and you're trying to find the third side. Soh-cah-toa is going to be helpful if you know a side and an angle. And the sum of the interior angles of a triangle is going to be helpful if you know two angles. So just pay attention to which tool you need in your toolbox. Here's a right triangle that we're going to solve. We've got the gamma angle is 90 degrees. Alpha is 41 degrees. I'm going to go ahead and label that. C is 10, and we want to figure out all of the other information in this triangle. So right now, I know an angle and I know a side, so I'm going to use soh-cah-toa. And because the angle is 41, let's go ahead and figure out either A or B. It doesn't really matter. I'm going to figure out A right now. I have to find all of them, so I'm going to do sine of 41 because it's opposite over hypotenuse, A over 10. And then I'm going to grab my calculator. I'm going to do 10 times sine of 41 degrees. Make sure you're in the correct mode. So I'm going to go back to my calculator. My mode right now is radians, so I'm going to change it to degrees. And I'm doing 10 times sine of 41. 6.561. I guess I could have found beta first because beta is an angle and I know two angles. So I know angle is 41 and another angle is 90. So since I know two angles, I can do 41 plus 90 plus beta is equal to 180, or maybe just 41 plus beta is equal to 90 because I pretty much know 90 minus 80 pretty clearly. So 90 minus 41 for that angle that's missing. Oops, I typed it in wrong, but we know it's 49. And then I now know an angle. I know two sides now. So since I know two sides, I can switch my tool to, I can do the Pythagorean theorem, or if I wanted to, I could keep doing soh-cah-toa. So I'll go ahead and do Pythagorean theorem. I know 10 squared is equal to a squared plus b squared, and I know that a squared is 6.561, so I'm looking for 10 squared minus 6.561 squared, and that's going to give me b squared. And then I'll take the square root of that. And I get 7.547. So be very comfortable with switching your tools as you do these solving a right triangle. There's often more than one way to get there, but sometimes you need to just be flexible. The other type of problem you're going to find are going to be either I give you a point or I give you one of the ratios and you're trying to find the other trigonometric ratios. So this one I'm given a point. So the first thing I'm going to do is I'm going to draw a reference triangle in the appropriate quadrant. Since it's -3, -4, my reference angle is going to be, my reference triangle is going to go to the x-axis and to the origin. You always go to the x-axis and the origin with your reference triangle. This is going to be the angle. So I know that this side length is -3, well, 3 is the length, and this length is 4. Because I'm in quadrant 3, I know that sine is going to be negative, and I know that cosine is going to be negative, and I know that tangent is going to be positive. So as I'm doing this, I'm going to be clever about that. So I've labeled the two given sides. I've drawn my reference triangle. Now I'm going to find the remaining side with the Pythagorean theorem. So 3 squared plus 4 squared is going to be c squared. I happen to know that triangle very well. So this side length is 5. Okay, so if I'm going to do sine, sine would be opposite over hypotenuse, but it's going to be negative. So it's going to be, so sine of theta is going to be -4/5. Cosine of theta is going to be -3/5 adjacent over hypotenuse. Tangent of theta is going to be positive opposite over adjacent. And then I've also got the reciprocal ones. So cosec, let's start with cosecant. Cosecant is the reciprocal of sine, so that's going to be -5/4. Secant is the reciprocal of cosine, so that's going to be -5/3. And cotangent is the reciprocal of tangent, so that's going to be +3/4. One way I can give you this information is by giving you a point. Another way I can give you this information is by giving you one of the ratios. So if I give you secant and theta is in quadrant 1, secant is going to be so I'm drawing it in the correct quadrant, and I'm dropping it down to the x-axis. And I know that secant is 1 over cosine. Secant of theta is going to be 1 over cosine. So cosine of theta is going to be 5/17, which means that the hypotenuse is 17 and the adjacent is 5. And so then I need to figure out what is the other length of the triangle. So 17 squared minus 5 squared is going to give me the other length of the triangle. And then I need to take the square root of that answer, 16.248. And so that means that tangent of theta is opposite over adjacent, so 16.248 over 5. And then I can also figure out the other 3 because those are the other 2, because I know secant. And then I can figure out, sine of theta is going to be opposite 16.248 over hypotenuse. And then all of those reciprocals I can also figure out. I was in quadrant 1, so I know that everything was going to be positive. Right. So that's our method for solving a right triangle, for finding the other trigonometric ratios if you have one of them, and make sure you remember your toolbox where you're going to need the Pythagorean theorem and you're going to need soh-cah-toa. All right, thanks so much. Bye.